This video will cover OpenCV, a widely used computer vision library. We'll explore how to read and display images and work with video processing. To get started, we first import the required libraries, OpenCV as CV2, and Matplotlib for displaying images. First, we import the required libraries, OpenCV as CV2 and Matplotlib. Next, we read the image using CV2 and store it in a variable called image. Then, we load the file image.jpg into this variable. After that, we print image shape to get the height, width, and number of color channels of the image. Next, we display the image using Matplotlib. First, we convert the image from BGR to RGB format because OpenCV reads images in BGR, while Matplotlib uses RGB. We do this using CV2 CVT color and store the result in a variable called image RGB. Then, we use PLT imshao to display the image. After that, we remove the axis using PLT axis off, so the image looks clean without numbers or grid lines. Finally, we call PLT show to display the image on the screen. Now you can see the puppy image displayed on the screen. Next, we convert the image to grayscale. This means we remove all color information and keep only the brightness values of the image. Grayscale images are often used in computer vision because they are simpler and faster to process. We use CV2 CVT color to convert the image from BGR to grayscale, and we store it in a variable called grayImage. After that, we display the grayscale image using Matplotlib. We use PLT imshao to show the image and set map equals gray, so it is displayed correctly in black and white. Then we remove the axis using PLT axis off for a clean view. And finally we call PLT show to display the result. Next, we resize the image using OpenCV. Resizing means changing the dimensions of the image to a specific width and height. We use the CV2 resize function and set the new size to 300 by 300 pixels. The resized image is stored in a new variable called Resize. After that, we display the resized image using Matplotlib. We use PLT imshao to show the image, then remove the axis using PLT axis off for a clean output, and finally call PLT show to display it on the screen. We crop the image by selecting a specific region from it. Cropping means we cut out a part of the image and keep only the area we need. We do this using array slicing in OpenCV. We take rows from 100 to 400 and columns from 200 to 500 and store the result in a variable called cropped image. Then, we display the cropped image using Matplotlib. We use PLT imshao to show it, remove the axis using PLT axis off, and finally call PLT show. Now you can see only the selected portion of the image as the cropped output. Next, we will draw a rectangle on the image using OpenCV. This helps us highlight specific regions of an image. First, we create a copy of the original image so that we don't change the original one. We store it in a variable called imgcopy. Then, we use the CV2 rectangle function to draw a rectangle on the image. We give the starting point of the rectangle as 100, 100, and the ending point as 300, 300. These 2 points define the opposite corners of the rectangle. Next, we set the color of the rectangle to 0, 0, 255. In OpenCV, colors are in BGR format, so 0, 0, 255 represents red. We also set the thickness to 5, which controls how thick the rectangle border will be. After drawing the rectangle, we display the image using Matplotlib. We use PLT imshao to show the image, and then we remove the axis using PLT axis off, so the output looks clean and professional. Finally, we call PLT show to display the final result. Now you can see a red rectangle drawn on the image, highlighting the selected region from 100, 100, to 300, 300. Next, we will learn how to add text to an image using OpenCV. This is very useful when we want to label images or add descriptions in computer vision projects. First, we create a copy of the original image so that we don't modify the original one. We store it in a variable called imgcopy. Then, we use the cv2putText function to write text on the image. We define the text as OpenCV tutorial and choose the position, 50, 50, where the text will appear on the image. Next, we select the font style as CV2 Font Hershey Simplex, which is a simple and commonly used font in OpenCV. We set the font scale to 1, which controls the size of the text. After that, we choose the color, 0, 255, 0, which represents green in BGR format. We also set the thickness to 2, which makes the text more visible. After adding the text, we display the image using Matplotlib. We use plt imshow to show the image, then remove the axis using plt axis off for a clean look, and finally call plt show to display the final output. Now you can see the text OpenCV tutorial written on the image in green color at position 50, 50. We apply Gaussian blur to the image using OpenCV. Gaussian blur is used to smooth an image and reduce noise, making it less sharp and more blurred. We use the CV2 Gaussian blur function and pass the image along with a kernel size of 15, 15, and a sigma value of 0. The kernel size controls how much blur is applied, and a larger value creates a stronger blur effect. We store the result in a variable called blurred image. After that, we display the blurred image using Matplotlib. We use plt imshow to show the image, then remove the axis using plt axis off for a clean display, and finally call plt show to see the output. Now you can see the image with a smooth blurred effect. Before working with OpenCV video frames, we can also display a video directly using IPython. First, we import the video display function from IPython. We use from IPython display import video. Then, we display the video file using the video function. We pass the video file name, for example video mp4, and set embed equals true so the video is embedded directly inside the notebook output. This allows us to play the video inline without opening any external media player. After running the cell, the video will appear directly in the notebook, and we can play it like a normal embedded media file. Next, we will understand how to read and display a video using OpenCV in Python in a simple and step-by-step way. First, we import OpenCV and create a video capture object using CV2 video capture. Inside the parentheses, we pass the video file name, for example video mp4. This tells OpenCV to open and load the video so we can work with it frame by frame. Once the video is opened, we use a loop to read the video continuously. Inside the loop, we use capRead, which returns two values. The first value is called read, which is a Boolean value that tells us whether the frame was read successfully or not. The second value is frame, which contains the actual image data of the current video frame. We check the value of read if read is false. It means there are no more frames left in the video or something went wrong while reading, so we stop the loop using break. If the frame is read successfully, we move to the next step, which is converting the frame from BGR to RGB format. This is important because OpenCV reads images in BGR format by default, but Matplotlib displays images in RGB format. So we use CV2 CVT color frame, CV2 color BGR to RGB, and store it back in the frame variable. After converting the frame, we display it using Matplotlib. We use plt imshow frame to show the image, and then we use plt axis off to remove axis lines and numbers so the output looks clean and professional. Then we use plt show to actually display the frame on the screen. This process repeats for every frame in the video, so it looks like a continuous playback of images one after another. Finally, after the loop finishes, we release the video capture object using capRelease. This is very important because it frees up the system resources and properly closes the video file. So overall, the process is, we open the video using video capture, read frames using capRead, check if frames are valid using read, convert frames from BGR to RGB, display them using Matplotlib, and finally release the video using capRelease. You've completed a full OpenCV crash course. You learned how to import libraries, read and display images, check image shape, and convert images to grayscale. You also resized images, cropped regions, and added text and shapes like rectangles. You applied Gaussian blur to smooth images and finally learned how to read and display videos frame by frame using CV2 video capture. This covers the basic workflow of OpenCV for image and video processing.